$205. That's the sticker price for the 10-meter cable we're breaking down today.
Wow.
And I know usually cables are like the most boring part of any tech setup. You just grab one and plug it in.
But this isn't really a standard cable. The NTI DP8K-FOCMP-10M-MM, at that price, you have to think of it more like a piece of industrial infrastructure.
Exactly. And the goal of this deep dive is to figure out, what exactly are you paying for?
Because it's not just a brand markup.
No. We're talking about a hybrid active optical cable that's trying to solve a very real physics problem.
It all comes down to bandwidth versus distance.
Mm-hmm.
This thing supports DisplayPort 1.4, which is pushing 32.4 gigabits per second.
To handle uncompressed 8K at 60 frames a second.
Right. A massive amount of data.
And that's the core issue, isn't it? If you try to push that signal through a normal copper wire over 10 meter, what's that, like 33 feet?
Yeah, about that.
Physics just gets in the way of the electrical resistance. It degrades the signal.
It attenuates until it's basically unusable. Copper's fine for short distances, a few feet. But at 10 meters, with that kind of bandwidth, you hit a wall.
Which is why this cable is active optical. It's using fiber optics instead of copper for the data.
Mm-hmm.
But the spec sheet calls it hybrid fiber and copper. And I think that's a crucial point. It's not just pure glass, right?
No, absolutely not. Fiber is incredible for moving data at the speed of light, but it has one big limitation. It can't carry electrical power.
Okay, that makes sense.
So inside this one jacket, you've got the fiber optic cores for that massive video stream, and right alongside them, you have copper wires.
And those are for power and the other lower bandwidth stuff, like the handshake signals?
Exactly. The signals that let the computer and the monitor actually talk to each other.
And the active part means there are little silicon chips inside the connector heads themselves.
Yes. The connector actually draws power from the DisplayPort source, using those copper rails to run a tiny converter.
So it's taking the electricity from my graphics card, turning it into light.
Shoots it down the fiber, and then another chip on the other end converts it back to electricity for the display.
So you're paying for a miniaturized transceiver system and using light instead of electricity for the actual video signal. That brings up another huge advantage: interference.
Complete immunity to RFI and EMI, radio frequency and electromagnetic interference.
Right. This is why the research notes kept highlighting places like medical imaging rooms or factories.
Yeah, noisy environments.
If you run a regular copper cable next to, say, an MRI machine or heavy motor, that copper acts like an antenna. It just picks up all that noise.
And you see it on screen as static or flickering or just a total signal loss. But glass fiber, it doesn't care about magnetism or electrical noise at all. You get a perfect pixel-for-pixel image.
Speaking of environments, we have to talk about the safety rating. This seems to be a huge deal breaker for commercial installations. The CMP-rated Plenum jacket.
This is where we move from protecting the signal to protecting the people inside the building.
So a plenum, what is that exactly?
In a commercial building, the empty space above a drop ceiling is often used for air circulation, for the HVAC system. That space is called the plenum.
Oh, okay. And if a fire starts?
That space basically becomes a wind tunnel for smoke.
Mm-hmm.
If you have cheap PVC cables in there, they'll melt and pump toxic fumes right into the building's ventilation.
Which is often more dangerous than the fire itself.
Way more. So a CMP, or plenum rating, just means this cable's jacket is made from a material that self-extinguishes and produces very little smoke. It's a legal requirement in most cases.
So part of that $200 price is just building code compliance.
A big part of it.
Now, there was one detail in the notes that really jumped out at me. It was about the Dell UltraSharp UP3D218K monitor.
Yes. One of the very few true 8K monitors out there.
The documentation says to run that specific monitor at its full potential, you actually need 2 of these cables.
In parallel, yeah.
That just puts the data requirements into perspective. Even with a pipe that can move 32 billion bits a second, some of these displays are so data hungry that one isn't enough.
You need dual inputs just to light up all the pixels.
It's a great reminder that the bottleneck isn't always the GPU or the screen. Sometimes it's just the pipe connecting them.
And this cable essentially removes that bottleneck. And the amazing part is, despite the lasers and chips inside, it's still just plug and play.
No external power brick or anything.
Nope. It handles HDCP, 32 audio channels, all of it.
So it performs like a piece of scientific equipment, but it acts just like a regular cable. That really feels like the big takeaway here.
I think that's a great way to put it.
So before we wrap up, here's a final thought. If a single 8K monitor today already needs 2 parallel fiber optic highways to work. What's the cabling situation going to look like when we inevitably start pushing for 16K? Thanks for listening to The Deep Dive.